Hi my friends, today we model this part which has some interesting features with the name bearing support box and the drawing with all dimensions here. Once again, the source for this model is from Timoteo Carrera Soto. I had to change some dimensions because there are mistakes. You see here 50 millimeters is this distance, and also 50 millimeters is this. This must be 30. This is a wrong dimension. I made some other modifications. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182, as you can see here. We can start our modeling. New standard millimeters IPT, sketch, XY plane, a line from the center to the right of 48 millimeters. You know now that this is a center line. I place this dimension somewhere up and we draw lines. This is the first, somewhere here, escape. Another line is this one, horizontal, and a line. I place an arc here with a radius of 14. All dimensions are in the drawing so that you can compare. This is a diameter of 40, the other is 82. I still move this. I also move this arc. We have a dimension here of 35, and I draw also the internal contour, and we'll use again the sharing sketches. I keep pressed the left button to create this arc. And if you take a look to the drawing, you see that this radii have the same center. This line must be horizontal, of course, and equal these two. This line must not be perpendicular, at so. I apply again equal to these two lines, and now I am sure of the symmetry. This is 5, this is 3, and these dimensions, diameters are 26 and 34. We continue by placing these two with the same center or concentric. This radius is 8. This diameter is 60. Is 54, and this is 26. Let's see what dimension is missing. I don't know, maybe only a constraint is missing. Let's see. Apply. Oh, I know what is. This dimension is 10 millimeters. Yes? Dimension of 10. You see, everything is maintained symmetrical here. And this is very important. Good. Now we have again, like in the previous tutorial, an external contour and an internal one. We start by creating the external, then we'll use sharing for sketches to create the other one inside the part. Finish sketch, revolve. This is external. The axis is already placed here, and we have the first volume. You see how it looks. Next is this wall. This, yes, which has dimensions right here. This is a rectangle, 22 with 5 thickness, placed at a dimension of 38 from this face and 30 from the axis. Let's create this sketch. XY plane, F7, rectangle, 22, tab 5. This is 30 and the other is 38. As you can see, this point is inside, and we'll see that this is resulting, but we'll see at the right time. extrude, symmetrical, and the dimension is 82, like the diameter of this circle. Okay, you see how it looks. Then we draw this contour with ending to this horizontal. We have dimensions here, radius 15, radius 10, and dimension 38, 50, 38. We draw half of this and then we mirror it as a sketch. Where is the plane? The plane is placed at 38 from this face. Okay, plane, face, minus 38. Sketch. We project this circle, and F7 we have it here. We start from this point down. I keep pressed the left button. I keep again press the left button. I draw a line. As you can see, I keep press the left button and I go to this point and back to the center point. I place this point on this vertical. I make equal this arc with the same radius like the other one. Dimensions are 50. Oh, I didn't draw this line. 50 is this, and 38 is between these two. 38. Radius here is 15. This is 10. And what dimension is missing? I change, of course, this dimension is also 38 between these two centers, lines, 38. Now we have a fully constrained sketch and we can apply mirror. Mirror what? These entities about this line. Also this must be, but I prefer to apply extend. Now we have to mirror it. Mirror this line about the same axis. Done. This is now construction, and we have the contour for applying extrude on 8 millimeters. This and this. 8, not 82. 8. don't want to see this, and we have the new feature. As I said, we have here a small extension. To cut it, we create a new sketch in the XY plane. Home, F7, project, this line and this ending segment. Then we draw a new line between these 2 points, then back to this line. Finish sketch, extrude, symmetrical all the way with cut. Okay, now we don't have any protrusion, extension here. Now we can use that sharing sketch to create the internal volume. I go to the first sketch and I apply share sketch. Then I apply revolve by using this internal, not all. The axis is present here. I apply cut. OK. Then I hide this and we simultaneously hide also this sketch. Visibility. Good. What next? Next are these bosses, which are 11 minus 8 height and diameters of 22 to each of the 3 arcs. Face, sketch, circle 22, then circles, and we'll make them equal to the first. Finish sketch, extrude, 1, 2, 3, 8, 11 minus 8. Okay. Now I have to place that holes of 10 millimeters. It's easy to use this face. Finish sketch, hole, not threaded, but simple, through all, this, and this, diameter of 10 for all 3. Okay. Next is this rib. You see better here. This rib with dimensions 6 millimeters thickness and 30 degrees here, starting from this very point. Good. I use the plane XY, F7, and I draw a line starting from this point to tab -90 minus 30. We have 30 the value. Tab 90 minus 30 because we have 30 as a value. The length is not important. As you know. Finish sketch, rib. I select this solution. I select this symmetrical. 6 is the thickness, and I select this profile. You see, 60. It is interesting that it extends also around this cylinder. Okay. Very nice. Now we have to place these holes with internal thread 3 times metric 4, equidistant. What is the distance? The distance is 70 divided by 2. I start with this one because it is vertical. You know the procedure from my previous tutorials. I draw a vertical line, not the length is 70 divided by 2. Finish sketch, hole, threaded isometric profile, 4 millimeters, and we select this endpoint. The depth, the total depth is 11, and this is 8. Okay. Okay. You see here the thread. I apply the chamfer of 0.5 millimeters. Okay. Then circular pattern for you see I cannot select chamfer. I have to select firstly the hole and then chamfer about this axis. Not 6 instances but only 3 instances. Okay. Now, as you can see in the drawing, undimensioned fillets are radius 2. They are all over. You see? Fillet, fillet, here, also here, and on the back as well. Oh, there is before we apply these fillets, which are radius missing radius. For you, apply dimension here. Annotate radius 6. I forgot it. I select edges, 2 millimeters is already applied or selected. A lot of fillets all around. This is not. Okay, and that 6 fillet to this edges. Now this is all the model. Let's see what about the volume. Update, copy, close, double click, a small difference so that we can eliminate the previous value and apply this one, because this is what we did here. Don't forget this radius 6. You can place it to be seen there. Now I apply material, which is steel cast, and the general aspect is gunmetal with the faces. I keep pressed the shift button when I select another face. Shift select. I keep pressed shift. I select all and I apply titanium polished, and we have a very nice model, isn't it? That's all for today. Thanks for watching. Bye bye.